Okay, so now we're going to look at lastly option pricing. Again, we will not go in so much detail because, like I said, treasurers usually have spreadsheets and calculators that calculate the option price very easily. But you still need to have some idea about what are the inputs and what type of models are used. So we're going to discuss just one model, which is the Black-Scholes option pricing model. This model is also known as the Black-Scholes Merton model, and it is a mathematical model for pricing an options contract. It is a model that has actually won the Nobel Prize in economics, and it uses differential equation to solve for option prices. However, this model is used to price only European options and does not take into account US options. So you can only calculate the price of European options from this. Wait, let me write it down. Okay. European options. And it does not take into account American options. Now, what is the difference between both of them? Basically, European options can only be exercised on a particular date, whereas American options can be exercised anytime till that date. So European can only be exercised on one particular date, whereas American can be exercised on multiple dates till that date on which the option is going to expire. So you can only calculate European option prices using this formula. Now over here you have the formula. I know it looks a bit scary, but let's break it down. So what does V stand for? It is the current value of the call option. So this is the formula to calculate the price of a call option. Then you have P. This is the current price of the underlying stock. So I'll denote this by P naught. Basically, this is the spot price. Okay, so then this price of the underlying stock is multiplying by this ND1. Now, what is this? This is a probability, basically. This whole thing represents probability that a deviation less than D1 will occur in a standard normal distribution. So basically, you have to figure out the value of this D1, then you will use the standard normal table to figure out the value that should come over here. So I'll show you that table later on as well when we do the practice question. Then what is X? X is the exercise or strike price of the option. So this is your exercise price. I think it's better if I write the things over here. This is the spot price basically of the underlying, and this is the value of the call option. Minus RF, so you have E minus RFT. Basically, you're calculating the present value of this exercise price. This is what is happening over here. This is simply calculating the present value of the exercise price. E numerically approximately stands for this, but you can just use the function in your calculators. R represents the risk-free rate, and T represents the time until the option expires, the option period. Always remember that the T has to be yearly. So if you are given an option of 3 months, you need to convert it into an year, which is 3 divided by 12. Similarly, if an option is for 60 days, you need to convert it by dividing it by 365 and converting it into year, and then you can use it over here. Then similarly, you have in D2. So this is the formula for D2. And this is again the probability. So you're multiplying the price and the exercise price, the spot price and the exercise price by two different types of probabilities. And this is the function of calculating D1, and this is the function of calculating D2. Now, I know it still looks a lot of confusing, so we will do one practice question to make it more clear to you. And over here you have ln px, which is the natural logarithm of p slash x. P is again the spot price and x is the call op, is the exercise price. And then you have this is simply variance of the rate of return of the stock. So the underlying stock, it is the variance of that, and over here you have the standard deviation of the underlying stock. The rest of the variables are the same. So let's do a practice question now. Close this. Okay, now these are some of the assumptions that based on which the Black-Scholes model has been derived. So you should be aware about the assumptions because that is a limitation of the model. So the assumption number one is that the stock underlying the call option provides no dividends or other distributions during the life of the option. There are no transaction costs for buying or selling the stock or the option. The short-term risk-free rate is known and is constant during the life of the option. Any purchaser of a security may borrow any fraction of the purchase price at the short-term risk-free interest rate. Short selling is permitted. We have already discussed what is short selling. And the short seller will receive immediately the full cash proceeds of today's price for a security sold short. The call option can be exercised only on its expiration date. So, like we said, that it is only for European options and it cannot be implemented to American options. Trading in all securities takes place continuously and the stock price moves randomly. So these are the assumptions based on which the Black-Scholes model has been derived. See, for any model, assumptions are always taken in order to derive that model. You should be aware of them so that you know what are the limitations of the model. Now, this is our example. So this is the information that has been provided to us. Now we're going to use it in the Black-Scholes model. So the price, this is your spot price is 21. The exercise price is also 21. This is basically your T. This is 0.36 here. Your risk-free rate is 5%. That means 0.05. And always convert your percentages into decimal. So whenever you get any information in percentage, please do convert it into decimals. Then you have the variance, which is 0.09. And of course, if the variance is this, then the standard deviation will be 0.3. I hope you are aware of this. Basically, if this is the variance, and you want to convert it into a standard deviation, you will take its square root, so this gets cancelled off. So if you take the square root of 0.09, you get the standard deviation, which is 0.3. Okay, now let's use this information in the formula. Okay, so first I'm going to calculate D1 because I need D1 and then I will calculate D2 and in the end I will calculate the value of the call option. So the formula for D1 was, let me first write down the formula. It was ln P divided by X, then plus the risk-free rate plus square 2 and T. So you just need to plug in the values correctly. That is it. It's not that difficult. Okay, so ln, what was the price? The price was 21. You can go back and see the data. And the exercise price was also 21. So we have this over here, plus the risk-free rate was 0.05. The variance was 0.09. This is divided by 2. Okay, so this is in bracket. And then you had T of 0.36. Then you will, over here you will not take variance. Over here you will take standard deviation. So 0.3 and multiply it by, again, the T, which is like this, 0.36. Now you just need to solve this. So first solve this, ln 21 divided by 21. Just plug in the values in your calculator. Yes, do use the brackets and remember to close the bracket. So you will get 0 from this plus, then solve this. So first solve the bracket, this one, and this, and then multiply it by 0.36. You will get 0.0342. And then over here you have 0.3 and this will multiply by 0.6. So this is 0.0342 and divided by 0.18, 0.19. This is your D1. Now using your D1, you can calculate your D2. D2. The formula for D2 was D1 minus this. So you have calculated D1, it is 0.19 minus this was, let me see, this was 0.3 and this is 0.36. 0.19 minus 0.18, you get 0.01. So this is your D2 value. And this one was your D1 value. Okay, make sure you do the calculation in the calculator so that you do not do any calculation mistake. Okay, now we can calculate the value of the call option. So the formula for the value of the call option was okay, let me first write down the formula in D1 minus X E minus R T N D2. Okay, so this is the formula. What is the stock price? It was 21. Now this value, basically you need N, what was D1? 0.19. You need to look this through a table. I'll show you the table. And then over here you have exercise price, which was also 21. E, this was 0.05 R, and your T was 0.36. So multiplied by 0.36, and then you have N, and D2 is 0.01. Okay, so now I'm going to take you to the table and we're going to look at this value from the table. Okay, so now if we go to the standard normal distribution table, remember that over here, let's look at the value. You're supposed to find N 0.19. So we're going to look for 0.19 in the table. Now this over here has negative value, so no, this is not what you want. Go below. Over here you have the positive values. Now the value that you want is 0.19. So this is 0.1. So you have to stay in this row and you want 0.19. So this is 0.1, this is 0.11, then this is 0.12. And 0.19 is over here. So 0.5753, this is the value that you want. And this is the value that you're going to plug in over here. Okay, so let me go back. Yeah, so this is the value that you're going to use. You're going to use 0.5753. This is the area under the normal distribution. Basically, this is a probability. Minus, then you can solve this portion. So if you solve this, you will get 20.625. Need to bracket close. And now you need N 0.01. So let's go back to the table and see where is N 0.01. So let me just keep this. So this is 0.01, right? So this is 0.0. The first two digits you want them 0.0 and then you want 1. So 0.504. This is over here. 0.5040. So let's go and take this value. 504. So now you can simply do the calculation. This will come 12.081 minus 10.395, 1.686. This is the value of the call option. So this is the price at which the call option is trading. This is the premium of the call option. Okay, so I hope the calculation is clear. You just need to know where to plug in the values. The normal distribution table I've already provided you in your folder as well. And apart from that, okay, now one more thing that I wanted to discuss over here, the time value, the intrinsic value, and the premium amount. Remember, I told you that premium comprises of two things. One is the intrinsic value, which we call the exercise value, and other is the time value. You have calculated that the premium is 1.686. Now, what is the intrinsic and what is the time value out of this? The intrinsic value is basically the exercise value. So over here, even your P was 21, even your X was 21. So if you exercise it, it will be 0. So the intrinsic value over here is 0, and this 1.686 is actually just representing the time value. So right now, you are at the money, but you are hoping that later on, because this is a call option, so you're hoping that later on the spot price will go up and you will profit more. But right now, the intrinsic value, the exercise, if it is exercise, it will lead to an exercise value of 0. So the premium that you're paying it for time, because you think that within time, most probably the prices will change, spot price will increase, and this will become in the money. So if the spot price, let's say, increases to 24 and the exercise price is 21, so 24 minus 21, then 3. This will become your exercise value, and most probably your premium will also change, because if it's in the money, the price of the call option will also go up. Okay, so now you should be aware about that which variable has what impact on basically the option price. So this is the base case, the one that we have calculated. And over here, you can see that one by one, we are changing each of the 5 variables. So basically, these are the 5 main variables in your option pricing formula, and you should be aware that what is the impact of each one. So if you increase price by 4, what happens? The price of the option increases. The value of the option increases. So if price increases, the spot price increases, the value of a call option is going to increase, because like I said, in a call option, you want this. And the call option, basically, if you remember, the intrinsic value formula was P minus X. So your profit is going to increase if P increases. So of course, that option will be more valuable to you if the spot price increases more than the exercise price. What happens if you increase X by 4? If you increase X by 4, you can see that the value of the call option actually decreases. So the value, because if you increase this, then of course the call option value is going to go down. Then what happens if you increase T? If you increase T, the value of your call option is going to increase. And this is true for call and put. Okay, so moving ahead to the risk-free rate. So you can see that if the risk-free rate is increased, it will increase the price of the call option. Now this is opposite for the put option. If the risk-free rate increases in the case of a put option, it usually decreases the price of the put option. And then over here you have volatility. Volatility, you can see that if it increases, it will increase the price of the call option. Now this is because if you think about an option that is not, a stock that is not that volatile and compare it to a stock that is very volatile, it gives a higher chance that the call or the put option will be exercised, because the price is fluctuating so much. So even if it's out of the money, there are highly likely chances that at some point it will go in the money. So for call and put both, this relationship holds true, that if the volatility increases, so will the price of the option. These are reverse for your put option, which means that if the price increases, the value of your put option is going to decrease. Because remember that the put option function is opposite. The put option function is this, the exercise value function. So if there is an increase in price, the value is going to go down. And similarly, if there is an increase in X, then that is good and that is going to increase your value. So this is the opposite for put options. Okay, so you should be very well aware of the impact of these different variables on your call and put option. Now we can also calculate the put option using another version of that formula, or we can even do it simply by using the put call parity. Basically, the put call parity says that there's a relationship, direct relationship between the call and the put price. So if we use that relationship, this is the formula that is derived through it. Basically, this is the value of your put option, value of your call option, this is the exercise price, risk-free rate, time, and this is the spot price. So simply by using this formula, which is much more simpler to use, so we're going to use this, you can calculate the value of the put option if you have already calculated the value of the call option. So let's do for the other, for that scenario. So let's plug in the values. The value of the call option was 1.686. The exercise price was 21. The risk-free rate was this, time was this, and this was the spot price. So if you do the calculations, your answer will come 1.31138. This is the value of the put option. This is the price, the premium of the put option. Again, this is the complete premium, right? 1.31138. What is the exercise value or the intrinsic value? In this case, it is also 0, because even over here, your exercise and your price are same, they are equal. So this is 0. So this is just your time value. You should be able to differentiate between exercise and time. And that is it.